All right, hey, ladies and gentlemen, hey, welcome back to um, to class here. So as you see, I'm not with you. I'm going to make a short little video for you, so you can take a look at some things as we prepare for calculus, some things that skills that we're going to need throughout the year in calc, and some of these things you'll see on the assignment we've done and worked on before calculus, but there's a few things that I wanted to throw in here and add that we have not talked directly about that I thought would be beneficial for us as we move forward. So the few topics here, and I'll keep this short and simple, is we've all sat through and been through trig, and one thing that we're going to need to be able to do is evaluate and simplify trigonometric functions. And so I don't know if you remember doing this in trig or not, but this was a big part of trig, and this is going to be definitely a big part of calculus as we move forward. And I wanted to refresh our skills on how we look at and evaluate some of these things. So if I had cosine of pi over 4, if you remember back in trig, there's a connection here, and since if I go around a circle one time, we know that to be 360 degrees, or that also is known in terms of radians as 2 pi. And so the connection is that anytime I see pi, at least what I think of is pi ends up being halfway around a circle, or that's 180 degrees. And so when I want to evaluate cosine of pi over 4, in my mind, I'm thinking, what degree is this? And so this is kind of like having 180 over 4. So I'm just substituting pi with 180. And this gives me an idea of what angle we're actually looking for. And this is really looking at cosine of 180 over 4, which is the same thing as 45 degrees. And so if I convert this top into radians into degrees, this is what it converts into. Now, the next question is, how do I evaluate this? Well, what we do is, if we remember the unit circle, 45-degree angle is right here in the first quadrant. If I create, because I know all these trig ratios, these things form and form right triangles, or firm right triangles, are where these trig ratios come from. Sorry, I'm struggling this morning. Cosine is the ratio of the adjacent over the hypotenuse. If I draw a right triangle, and this is my 45-degree angle in the first quadrant, I need to know the ratios for a 45, 45, 90 triangle. And if I remember that they're 1, 1, square root of 2, those are my ratios. And since I'm in the first quadrant, everything is positive. I get a picture that looks something like this. And so if I want to evaluate, well, what is the adjacent over the hypotenuse? Well, from 45's perspective, the adjacent leg is 1. The hypotenuse is the square root of 2. And so when I write those, I get 1 over the square root of 2. And as we all know, if we rationalize, multiply the top and bottom by the square root of 2 over 2, I end up getting an answer of the square root of 2 over 2. And so when they ask us to evaluate and simplify, I want you to find the exact answer. I don't want us to type this in our calculator and write this as a decimal, but the exact value ends up being the square root of 2 over 2. This is a skill that we're going to need to be able to do throughout the entire year in calculus, is evaluating trig functions and what they are. Should we try one more here? So maybe you try this one. So sine of 4 pi over 3. If someone wants to pause the video and try it on your own first before I come back on. Okay, sine, again, I would think of this as being 180. So 4 times 180 divided by 3, I think gives you an answer of 240 degrees. So in my unit circle, again, thinking of 240 is easier for me than thinking it as 4 pi over 3. Some of you, maybe you can just do it in radian mode yourself, but 240 degrees is going to be all the way here in the third quadrant. And I'm going to have 180. This is actually going to make a 60-degree angle. Again, I always go back to the x-axis when I form my triangle, but this ends up making a 30, 60, 90 triangle. Again, I didn't draw mine at all proportionally the way it should look, but the rules for a 30, 60, 90 triangle are the short leg is across from the small angle, that's 1. The hypotenuse is 2. The long leg is the square root of 3. So for a 30, 60, 90 triangle, it's 1, 2, square root of 3 is my rule. Now, the only thing to be careful on here, since we're in the third quadrant, I'm going to the left, which means this is going to be a negative. I'm going down, which means this is going to be negative. So sine, though, is what ratio? Well, sine is the ratio of opposite over hypotenuse. So ours, what's opposite of my 60? Opposite is the negative square root of 3 over the hypotenuse, which is 2, and I should get a negative square root of 3 over 2. The other thing to remember is, I know in trig, I know Mr. Blurch teaches this, I teach this way too. All students take calculus. This is a way to check your answer. Again, in the third quadrant, the T stands for the only function is tangent and cotangent that are going to be positive. All the other functions should be negative. So since we had sine and it's in the third quadrant, we'd expect it to be negative, which it is. Again, first quadrant, everything's positive. Second quadrant, only sine and its reciprocal function, cosecant, are positive. Third one, only tangent. Fourth one, only cosine and secant are going to be positive. So today you're going to be asked to do a little bit of simplifying, evaluating on trig functions. That's a skill that I want us to be great at as we move forward. The other thing today you're going to see is this, and this is kind of opposite of what you expect, but we're going to be doing this shortly in a few weeks here. Rationalizing, most of the time we always say rationalizing the denominator in algebra because we don't want to divide by something that's irrational that goes on forever. As you'll see soon with limits, we are going to need to be able to rationalize both the denominator and the numerator. And so this is a little bit different, but I want to rationalize the numerator. And if we don't remember this, if I have radicals, which I do up on top, and I want to rationalize, I want to get rid of my radical up on top. And so we do it the same way we would if we had a radical in our denominator. We're going to multiply by its conjugate. But I'm going to choose to multiply the top and bottom by a well-chosen 1, a value of 1. And what I choose is I choose the conjugate of x squared of x plus 5, which is the square root of x minus 5. Sorry, it's supposed to be minus 5. But I have to multiply the denominator by the same thing. Whoops. And in doing so, I'm going to end up getting, in my denominator, I'm going to get x, and then I'm going to have the square root of x minus 5, like that. And we're going to leave it like this. I know we're going to get a radical in our denominator, and that's against everything we want, but there is going to be a time in calculus with limits where that's going to be okay, and I'll explain why. But how do I deal with the top, though, when I multiply conjugates? I'm just going to FOIL this out and take first times first, which is x. Then I'm going to take the second, which is going to be minus 5 square roots of x. Then I do the inside, which is going to be a positive 5 square roots of x. What happens to those? They're going to cancel, so the inner parts go away. When I do the last, though, I end up getting minus 25. And so our answer is going to look something like this. We're going to have on top, we're going to have x minus 25. On the bottom, we're going to end up having x, and then in parentheses, the square root of x minus 5. And today, when they ask you to rationalize the numerator, what that means is I don't want a radical in my numerator. And so if I take a look closely at this, do I have a radical in my numerator? No, there's no radical in my numerator. There is one in the denominator, and if we rationalize that, we'd go back to where we were, but we're not going to do that. So today I just wanted to show you a couple things, and I'll stop right now, but I'm going to ask that we try some of these things, look back. This is all review of things you've done before, but I wanted to point out a couple of highlights, some pieces, so that you could be successful moving forward. Have an awesome day. Thank you for working hard. I'm excited for what's in store for us.